Hello viewers, in front of you is Mr. Wanyoike himself. Welcome to Mr. Wanyoike, the digital learning platform. I am a mathematics teacher. In today's lesson, we're in lesson number 3 and I'm going to look on divisibility test. On to the divisibility test, the area number 1 that I'm going to look at, I'm going to look on divisibility test of 2. Divisibility tests of 2, and therefore in this divisibility test, a number is divisible by 2. A number is divisible by 2 if its last digit is even or 0. That statement is very important. You are supposed to always note that. In example, an example here, you can be asked, determine whether the following numbers are divisible by 2 or not divisible by 2. And the first example I'm going to work with, I'm going to use 342, and also I'm going to move to the next one. And the part B of the question, you are supposed to test whether 947 is divisible by 2 or not. To start with, I'm going to ask myself, is 342 divisible by 2? The answer is yes. Why? Because in 342, the last digit is 2 and 2 is an even number. And therefore, I'm going to write 342 is divisible by 2 since its last digit is 2 or is even. In other words, it is even. And therefore, that is exactly what you're supposed to do. And you can use a long division method to verify whether my statement is correct. In long division method, I'm going to use 2, then 342, you divide by 2. You put a 2 here. Sorry, you're supposed to start with 1. 1, you multiply by 2, you'll get 2. Then you subtract, you get 1, you drop 4, then you write 7 because of 14, and lastly you are supposed to drop 2, and 2 you write 1. 1 you multiply by 2, you get 2, and therefore you get 0. The answer, the last part there is 0, and therefore meaning that our answer is 171. 171 is the quotient, as far as that question is concerned. And therefore in the second part of our question is 947. 947 is not divisible by 2. Why? Because the last digit is 7, and 7 is not a 0, and also it is not an even number, and therefore I'm going to write a statement here, is not divisible by 2. Then I'm going to move to divisibility test of 3. Divisibility tests of 3. A number is divisible by 3. A number, that is a statement, very important, is divisible by 3 if the sum of its digits, is divisible by 3 or forms a factor of 3. That is, in other words, an example here, you can be asked in an example, you can be asked, determine whether the following numbers, the question reads, example, you determine whether the following numbers are divisible by 3 or not divisible by 3. And the first example that I'm going to give here, it is supposed to be 1257. In other words, 1257. Is it divisible by 3 or is it not divisible by 3? And what you're supposed to do, you're supposed to take 1, the digits, you get the summation of the digits, you add to 2, then you add to 5, then you add to 7. And what is the answer? 1 you add to 2, you get 3, 3 plus 5, you get 8, and 8 you add to 7, you will get 15. And therefore 15 becomes the sum of the digits, and therefore 15 is divisible. 15 is divisible by 3, because 15 is a factor of 3, and therefore 15 is divisible by 3, and therefore you conclude, therefore 12, that is 1257, 57 is divisible by 3. Why am I saying it is divisible by 3? Because the statement reads that a number is divisible by 3 if the sum of its digits is divisible by 3. And since the summation of the digits, that is 1000, of the number 1257, the summation of the digits becomes 15, and 15 is divisible by 3. Therefore, 1257 is also divisible by 3. The second example, I'm going to give a number, another example. I can give a number like 274. 274. Is 274 divisible by 3? Let us put it into test. 2 plus 7, then you add to 4. 2 plus 7, you get 9. 9, you add 4, you will get 13. And 13 is not divisible by 3. 13 is not divisible by 3, and the sum of the digits are giving us 13. And since 13 is not divisible by 3, 13 is not divisible by 3, meaning that 274 is not divisible by 3, and therefore we are going to make a conclusion. You write therefore 274 is not divisible, is not divisible by 3. Our next example, I'm going to look on area number 3, that is the divisibility test. The divisibility test, the next area that I'm going to look in this session, I'm going to look on divisibility test of 4. Divisibility test of 4. A number is divisible by 4 if its last 2 digits. A number is divisible by 4 if its last 2 digits are divisible by 4 or are both 0. So an example, I can come up with an example here. The example part A, determine whether the following number is divisible by 4 or not, and I can come up with 100. So looking at 100, you can see that the last 2 digits is 0 and 0, and therefore since they are both 0, we can say that 100 is divisible by 4. Since the last 2 digits are both 0, both 0. Can write that statement, very important, are both 0. Therefore 100 is divisible by 4. It means that you will divide it by 4. 100 is once it is divided by 4, you are going to get a whole number. You are going to get the quotient without having a remainder. The second example, I can look at 111. Is this number divisible by 4? You just look at the last two digits. The last two digits is 1 and 1, and 1 and 1 is not they are not both 0, and also 11 is not divisible by 4, and therefore we can say that 111 is not divisible by 4. Another example, we can look on 124. 124 in this case 124 is it divisible by 4 or not? We look on the last two digits. The last two digits is 2 and 4, and 24 from our division here you can see 24 is divisible by 4, because 6 you multiply by 4 you get 24, and the answer becomes the quotient in this case becomes 6. The quotient is 6 and there is no remainder. Therefore, since the last two digits in 124 forms a number which is divisible by 4, we can say that 124 is divisible by 4. It is divisible by 4, and that is the conclusion that we are going to make. Having said that, I'm going to the divisibility test of 5. I'm going to the divisibility test of number 5. When do we normally say that a number is divisible by 5? I'm going to illustrate it, divisibility test of 5. And whenever we come to divisibility test of 5, a number is divisible by 5 if the last digit is 0 or 5. So you should be very keen. A number is divisible by 5 if the last digit is 0 or 5, and therefore as far as divisibility test of 5 is concerned, you are supposed to look on the last digit, and if the last digit is 0 or 5, then you say that that particular number is divisible by 5. An example of divisibility test of 5, divisibility tests of 5. I've said that a number is divisible by 5 if its last digit is 0 or 5. Example 1. Determine whether the following numbers are divisible by 5 or not. So in this example, I'm going to put part A 150. The second one, I put it as 163, and the other one, I put it, part C, I will put it as 155. And therefore, we can look on the statement whether they will give us, according to the statement which I've written here, 150. The last digit in 150, part A of the question, is 0. And therefore, since it is 0, we can say it is divisible by 5, since the last digit is 0. Yeah, it is divisible. It is divisible by 5, since its last digit is 0. So that is the statement. What about this one? It is not divisible. It is not divisible by 5, since its last digit is neither 0 nor 5. So it is null 5, and therefore what about this? As far as the part C is concerned, we can say it is divisible. It is divisible. We can start, I write by writing it is divisible by 5, since its last digit is 5. So we can say that it is divisible by 5 since the last digit is 5. Another example, another part of study, we are going to look on divisibility test, divisibility test of divisibility test of divisibility test of 6. And therefore a number is divisible, by 6 if it is both divisible by 2 and 3. And therefore I'm going to give an example here. Determine whether the following number is divisible by 6 or not divisible by 6. The example that I'm going to put it in this question, I'm going to refer to 612. 612. So you must, when it comes to divisibility test of 6, you must test with the divisibility test of 2. First, 612, it is divisible by 2 since its last digit is even, and that is the even number is 2 in that case. And what about the divisibility test of 3? Because whenever you are considering the divisibility test of 6, you have to consider both the divisibility test of 2 and 3. And therefore, for the divisibility test for 3, that is, you take 6, you add 1, then you get the summation of the digits. So you'll end up getting 6 plus 1, you'll get 7, 7 plus 2, you'll get 9. And 9 is divisible by 3. 9 is divisible by 3. Hence 612 is also divisible by 3. And therefore, since 612 is both divisible by 2 and 3, we can make a conclusion. Therefore, 612 is divisible by 6. So we can make that conclusion that 600, therefore, there is a therefore here. Therefore, you write therefore. Therefore, that is our conclusion. Why are we saying, are we concluding this way? Therefore, 612 is divisible by 6. Why? Because it is both divisible by 2 and also divisible by 3. Having said that, in this particular question, you have to be very keen, because if you are given another example and you find that it is only divisible by 2 but not divisible by 3, then the conclusion will be it is not divisible by 6 because it is only divisible by 3 and not divisible by it is not divisible by both 2 and 3. And therefore, for you to make a conclusion that it is divisible by 6, it must be both divisible by 2 and 3. That is the divisibility test of 6. What about the divisibility test of 8? Divisibility tests of 8. An example. I'm going to give an example. A number is divisible by 8 if the last 3 digits are divisible by 8. If the last 3 digits are divisible by 8. For example, you can be asked, prove whether the following number is divisible by 8 or not. And the number is 30. Then we have 27, 144. So you are supposed to take the last 3 digits and you divide them by 8. Divide them by 8, and therefore the first one you are going to get a 1 there because of 8. Then you'll get 64 because if you subtract 14 minus 8, you'll get 64. 6. Then you drop 4, you end up getting 64. Then you put an 8 there. Then 8 you multiply by 8, you get 64, and you can see there is no remainder. And since the last 3 digits are divisible by 8, therefore you make a conclusion. Therefore, 27, 144. That is that is 3,027,144 is divisible by 8. What about the divisibility test for 9? What about the divisibility test for 9? Divisibility test of 9. A number is divisible by 9 if the sum of its digits is divisible by 9. For example, a number is divisible by 9. I've said a number is divisible by 9 if the sum of its digits form a number which is divisible by 9. An example, I can come up with an example. The example in this case, I'm going to use 1, 3, 7, 1, 3, 7, 1, 3, 7, and also I can put 7. Is that divisible by? Is that example 1 divisible by 9? Let us see. 1 you add to 3, then you add to 7, then you add to 7. 1 plus 3 you'll get 10. 10 plus 7 you'll get 17. That is 1 plus 3 you will get 4. Sorry, 1 plus 3 you get 4. 4 plus 7 you will get 11. 11 plus 7 you will get 18. And you can see 18 is divisible by 9. It is very evident that 18 is divisible by 9. How? By 9. You will get 2 then because of 18. And therefore, since 18, which is the sum of its digits, is divisible by 9, then we can conclude, we can make a conclusion that 1,000, the number given was 1,377 is also divisible by 9. It's also divisible by 9. Divisibility test for 10. I'm going to move to the next one, the divisibility test for 10. And as far as the divisibility test for 10 is concerned, you are supposed to understand that a number is divisible by 10 if the last digit is 0. If the last digit is 0, then that number is automatically divisible by 10. And therefore, that is the divisibility test of 10. Divisibility tests of 10. I've said that a number